All right, hey everybody, thanks for watching this video. We're going to get started here with just a quick review on something that you actually do already know, which is how to distribute something. Then after that, we're going to learn how to distribute variables. And then after that, we're going to learn something called reverse distributing, and I'll give you a more formal name for that in a few minutes. But to get started here, let's just take a look at these top 4 problems, and you can see I've already got the answers written in here for you because, like I said, this is a review. So for the first one, when we're distributing the 3 on the outside, that means we're distributing the 3 to the x and then the 3 to the 5. So 3 times x is 3x, and then 3 times 5 is positive 15. So we get 3x plus 15. For the next one, when we distribute 2 to y, we get 2y. And then 2 times 7 is where I got the plus 14. So 2y plus 14. Now we can distribute fractions. So we have a 2/3 times w, which is just a 2/3 w. And then when you have the 2/3 of the 9, you might remember that there was a couple different ways we talked about this school year for that. You could do 2 times 9, which is 18, and then 18 divided by 3. Or you could do 9 divided by 3, which is 3, times 2. Both of those give us the 6. Also, friendly reminder that when it was the minus in here, since it's a positive times the negative, that's why we have the minus 6. So 2/3 w minus 6. And last but not least, we could take a half of m, and then a half of the 8 puts me at 4. So this is 1/2 m plus 4. So that's just a quick review again on something that you already know how to do. And now let's take a look at some examples if we are distributing variables, okay? So for this first row here, we've got an a on the outside, and we're going to distribute that to an x plus y on the inside. So a times x becomes ax, and then a times y becomes ay. So this is now ax plus ay. For the next one, we're distributing a -2 to a y, and then a -2 to an m. So -2 times y is minus 2y, and -2 times positive m is a minus 2m. All right, for the next one, we're distributing a fraction. A -2/3 to w is a -2/3 w. And a negative times a negative is going to actually be here. We got to catch that that's a positive. And when we do the 2/3 of 9z, that's going to be 6z. Again, 2/3 of 9 is 6. It's up here in the corner. And when we do the 2/3 times the 9z, we have to leave the z in our answer. And that's, again, what we're learning how to do here, distributing with the variables. And for the last one, when we have the 1/2 times 6m, half of 6m's would be 3m's. And then half of 8n's would be 4n's. All right, so that's the first 4 examples. If you have any questions on those, just pause the video and come see me. All right, now here we've got several more, and I'm just going to keep working through them. So x times 2, we write that instead of putting an x and then a 2, you guys know that we always put a coefficient before the variable. So even though it's an x times 2, when we write that, we're going to write a 2x. And then x times -g is going to be minus xg. Now the coefficient with the number, that needs to come first. But whenever it's the x times the g like that, it's okay that you just have x then g, like how I have it written. Same thing in this next example. See how it's just a times g, so it's okay to just put ag. And then an a times -2 is going to be minus 2a. All right, next example, x times m is xm. And then x times -1, x times -1, anything times 1 is still itself. So notice that instead of putting a minus 1x, I'm just letting it be itself. X times 1 is just x. And because there was a minus sign here, that's why I keep the minus sign in the answer. And for the last one in this row, we've got x times k, and then x times m. So that becomes xk plus xm. So earlier in the year, we had done it with just numbers on the outside, and now we're learning that we can also potentially distribute letters as well, the variables. And now we've got just 3 more examples. So an a times 4c becomes 4ac. Notice again, the number is written first, just like always, like a coefficient. And then we still just have the a and then the c, so there's the ac. Now there's a minus, and then a times minus 3b. The 3 still comes first. but then we have the AB part of it. So when we distribute an A times a negative 3B, that becomes minus 3AB. All right, for the next to last one, we have A times B is just AB. And then A times the negative K is going to be minus AK. And for the last one, I have it handwritten here, but there's a spot for it in your notes. We've got 2A's times 3B's. Now with this one, we have a number and a number. So 2 times 3 is 6. And then we just have AB. And now 2 times this negative 2 becomes a negative 4. And then we still have the A times C. So this is minus 4AC. So this is all the different ways I could throw this at you. We've got fractions that we've distributed here. We have a letter to letters. We have numbers to letters. And down here, we even have, if there's a number and a letter, and then number and letter and number and letter. So these are all the different possible ways you could have to distribute with some variables. Okay? All right, now is where we're going to actually learn the thing, though, for something called reverse distributing, which has a different name, and it's called factoring. Okay, now factoring is something that you have learned about already. And let me just review a little bit what you know about factors. So if I take the number 10, here are all the factors of 10. I could do 1 times 10 to get 10, or I could do a 2 times 5. So if I'm listing out all of the factors of 10, I'm going to list out these numbers: 1, 2, 5, and 10. So these are the factors, okay? Now if I take the numbers 10 and 15, so 15 has a couple. We've got 1 times 15, nothing times 2, but 3 times 5. So if I list out the factors of 15, we've got a 1, a 3, a 5, and a 15. So the thing you did in elementary school was learn how to identify something called the greatest common factor, which is like what's the biggest number that goes into both of these numbers. And y'all would identify that here as a 5. 5 is the biggest number that goes into both of these, okay? Real quick, let's just try another example. What's the biggest number that goes into both 12 and 18? Just think about that one for a second. What's the biggest number that goes into both 12 and 18? Hopefully you're getting that that would be a 6. 6 is the biggest number that goes into both of those. What if we did a 15 and a 30? What's the greatest common factor of 15 and 30? Well, that one would actually be the 15 because 15 goes into itself and it goes into 30. So we have talked a little bit in elementary school about factoring and what that is and finding like the greatest common factor. What's the biggest thing that goes into both of those? So now let me show you what that looks like in today's lesson. If we start out with a thing that has AX and AY, let me ask y'all, what do you see in both of these terms? Both of these terms have an A. So this is the greatest common factor, and this is the thing that's going to come out. And then what we'd be left with is x plus y inside the parentheses. And to check if we were to distribute, we've got ax and then plus an ay. So to check, we're distributing, but to get the answer, we're basically undoing the distributive property. In case you're still not quite getting it, it's basically like if we did up above the distributing part to get this answer, now I'm just taking this answer and saying, hey, how do I work backwards to see what was distributed? And when you work backwards to see the little thingy that got distributed, that is you factoring out the greatest common factor. So let's just do a few more examples here, okay? So when we see the negative 2y and the negative 2m, what do both of these things have in common? It's the negative 2. So that gets factored out. And then now just ask yourself, if you were distributing, what would you have to multiply a negative 2 by to get negative 2y? Okay, so y. And then what would you have to multiply negative 2 by to get negative 2m? And that would just be an m. So we're going to put plus m there. Now you can always check your work by actually just distributing again and seeing if you get that. And if you do, you know you're good to go. All right, so for the 3x and the 15, now here's where it gets a little bit tougher because these both don't have x's and it's not the same number like we had here. But I think you guys would agree that the greatest common factor of the numbers 3 and 15 is a 3. So the biggest thing that can go into both of these is a 3. And if we were to distribute a 3 to an x, we'd get 3x. and then we would need to distribute 3 to a 5 to get the plus 15. So that's where I'm getting 3 times x plus 5. All right, in this next example, we have a 4x and a 10y. So the letters aren't the same. And now let's look at the numbers. We have a 4 and a 10. What's the biggest number that goes into both 4 and 10? Well, that would be a 2. So 2 gets taken out. And then now let's just, again, reverse distribute. 2 times what would give us 4x? Okay, so that would have to be a 2x. And then that would be the 4x to check. And then 2 times what gives me this 10y? So that's where we put in the plus 5y. All right, let's just see a few more examples to just keep practicing. And the kind of the process here, if you want to take notes on this, basically the process is you look at both of the terms to see if there's anything they have in common. That's you identifying the greatest common factor, or the GCF. And you can check all of these, again, simply by distributing. Okay? So let's look at a few more examples to try to get comfortable with this. We have a 3x minus an xg. These both have an x in common, so x comes out. And then the thing that's left on the inside would be the 3 here, and then the minus g. So x times 3 minus g. And again, I can kind of highlight it, or actually not even highlight it. Let me, if I use the a white, like a whiteout marker, if we take the x out of this term and the x out of this term, do you see how 3 minus g is what's left and we took the x out? So again, that's just like another way to kind of see that. In the next example, again, I can kind of white out what they both have in common. These both have a g in common. So if I took the g out of this and the g out of this, the a minus 2 is what's left over, and the g got factored out. Same for this third example. If they both have an x in common, if I took the x out, I'd have m. And if I took the x out here, that has to be replaced with a 1. And so here we can see if we took out the x and then check by distributing, this would be xm, and x times 1 is still itself, and so there'd be a minus x. So if we check by distributing, this thing in red is what we get. And now if I just show you the original problem, that's the xm minus x. So we know we're good to go. So if the letter is the same in both, and it's just the letter again over here, you're going to have a 1. And to kind of reinforce that concept, I have another example right here, y'all. See how there's an A and an A? So we're taking out A. And then when we take out the A, AB was the AB, and then A times itself, or sorry, A times 1 stays itself. So that's why we need the plus 1 there, because this would be plus a 1A, and we never have to write the plus 1A there. All right. And now we just have 2 more. These look a little bit trickier, but they're actually not. We have a 4xy and a 3xz. So 4xy and 3xz, there's nothing in common with the 4 and the negative 3, but the x is in both, so we're going to take out the x. If I take the x out of that, I've got 4y, and if I take the x out of this, I have minus 3z, and that's what's left over in the parentheses. And now for the last example, I think we all see that they both have an a, which is awesome, so we're going to take out a, which is right here. But between the 6 and the negative 4, both of these have a 2. So we're also going to take out a 2. And if we've taken out 2a, the greatest common factor here is 2a, just think, okay, what do I need to multiply 2a by to get 6ab? So 2 times 3 is where I get the 6. And then ab, so we need a b here. So if we did 2a times 3b, that would become 6ab. So we're good to go on that one. And now we need this 2a to be multiplied to become minus 4ac. So that's why you see the minus 2c, because 2 times negative 2 becomes a negative 4. And then the a times c would be an ac. And you can see right there we have basically the original problem. So we have undistributed or factored correctly. All right, so now that's kind of what today's I can statement is I can factor out the greatest common factor in an algebraic expression. That's the goal here. So what you're going to do now is you're going to practice on your own with the rest of the page. You're just going to practice factoring a little bit more on your own. You're going to put the answers into the Google form, and then you're going to be ready for the next page in our packet, page 6. All right? That takes care of today's video. Thank you for watching.